How you doing?
I'm doing good, man. How you doing?
Doing pretty well. Hanging in there, trying to survive the winter. Everything is gray outside. It's just, why do we live in the Northeast?
It's hard to explain to people. It's like, oh, there's days where it's overcast and cold and stuff, but there's a combination. It's just like a blanket that just settles on the city for 3 months.
You know what the worst part is? Is that people from Florida, you, are always talk about how much you love the seasons. I'm like, really? You love the seasons? Well, this is the seasons.
See, this in the winter, this is my goal is to go to get a lake house in Lake Tahoe because then it's very nice.
There you
It's
go.
pretty,
There you go.
But January to March, anyone who is planning on visiting New York City, don't come between January and March. There's no reason to be here.
Well,
Cool,
on
man.
this positive note, let's
Yeah.
let's kick
Well,
off
that's why
the
we're
pods.
here talking tech with all of our friends.
Yeah.
I gotta say, I've really been enjoying like Twitter lately. I don't know if I'm on For You or following these days when I open it up, but it shows me a lot of the stuff I'm interested in, lots of the RSC discourse with folks from React and other frameworks, and it's been good. And people seem to be sharing more stuff these days too than they were like a year ago for sure.
Yeah. Yep. I find For You and then aggressively mute accounts that you don't want to
Mm-hmm.
see.
Mm-hmm.
I notice when you go to For You, you get a lot of like the meme accounts and
Yeah.
just a lot of and if you just mute all those, you'll start to get just like good tech. So
Yep.
yeah,
Because I was doing, yeah, they cater to the worst of us, and I'm like, I just see
yeah,
dogs,
exactly.
and I'm like, I'm not on Instagram, and I'm gonna interact with every dog post I see, but I don't. That's not what I want to see when I open up Twitter. So, um,
Well said.
but yeah, I think yeah, lots of cool RSC stuff going on. Excited to see some of the developments happening in Remix and Next. And we talked about your framework a little bit last week. I think a lot of people are experimenting with their own implementations,
Yeah,
just to see what the most simplified version of the model is. So I'm going to be excited to be making some videos on that stuff when I can play around with it.
very cool. Very cool.
You got a YouTube video you've been prepping this week, and this kind of came from what we were talking about yesterday with related to RSC. Was like we were talking about the cache, and you were working on a demo, or you were working on an app when you were
Uh,
talking
so
about the cache from Next versus the cache from React.
yeah, I've had on my list of videos to make is a video that explains React's cache. So there is an import from React. You import cache from React. I guess you do like the destructuring, but yeah, you import cache from React. Uh, and I think when you talk about caching in RSCs, since Next is the most popular RSC implementation, it is like the best production ready RSC implementation. Next also has its own cache. And so it's really easy to just talk about cache and mean like five different things when you're talking about RSCs. So I've wanted to make this video for a while where we look at the cache from React outside of Next, just React's cache helper, what it does, why it exists. So I guess like to tee it off, let's talk about the cache from Next. Next's caching is meant to be like a long-lived cache that helps you. They have a whole bunch of different caches: a client-side cache, a fetch cache. They have ISR, which would be like a page cache almost. But just setting all those aside, all of those caches, they're meant to be long-lived caches, more of how you think of like Redis or Memcache. You do work once, and then you can reuse that work over and over again until the data changes. So you
And we're
could
talking about
potentially.
server side here, or it's
They
more
have
you're
client
speaking
side
more
and
generally.
server side. Yeah, I'm speaking more generally. Just the idea of caching in Next
Hmm.
is this idea that, and we can talk specifically about like ISR and the fetch cache. Those are both server side caches. But the idea of caching in Next is probably what most people consider when they think of caching, which is basically do some work up front, stuff it in a cache, and then just keep reusing that over and over again until I invalidate it. When do I invalidate it? Maybe I have a webhook that invalidates it when my CMS changes, or maybe I just manually invalidate it. Maybe I invalidate it every 3 hours. I just hard code 3 hours in there. But the idea is it's more of a long-lived cache, if that makes sense.
Mm-hmm.
React's cache helper is a short-lived cache. So when you import cache from React, you can cache things. You can cache the results of functions. You can think of it like memoize. Cache the result of a function, and that cache only lives for the render of your RSC. So you start rendering an RSC, you start caching things, and then RSC renders over, and you throw away the cache. So
So
it is
now,
not like a yeah.
now
Go
are
ahead.
we talking about server side only, or
Yeah, great question. Yes, but we'll come back to that and we'll
we'll
go
put an
a little
asterisk
deeper
there?
there.
So when you
Yeah.
say you said the render of the RSC, maybe the general way is like it's not long lived beyond like the environment or like the session or like the
Let's think about it in
request.
terms of yeah, if we're going to think about it in terms of HTTP, which I think we should for this
Okay.
conversation, it is
Okay.
going to be the request. So a
Okay.
request comes in, you start rendering a RSC tree. So it's basically a bunch of React server components that are all kind of composed together. Cache starts, you finish the render, cache ends, throw the cache away.
Got you. Okay.
So very,
So
very short lived. I mean, we're talking like this could be lived for like 40 milliseconds,
right,
extremely
right,
short
right,
lived.
right. Got you. So no durable place to store it afterwards, and it's kind of like this. This
That
reminds
is a
me
that is a that is a great point. It's stored in memory. It's not a
in memory,
durable.
right?
Right.
And it reminds me of like Rails has some built-in caching before you add something that is durable like Redis. Just the application code talking to the database. Rails can has some things where if you do something like get the current user, it has to fetch it from the database. But if you're within a single request response cycle, it will be memoized, like you said. And so current user will just return a reference to something pointing in Ruby memory so that it doesn't have to go to the database again. So that's the kind of thing we're talking about.
Yeah, exactly. So Rails, when a request comes in, instantiates a whole bunch of controllers and then uses those controllers for the request. I guess it really just instantiates one controller, but uses
Mm-hmm.
that controller for the request. And then when the request is over, it destroys
Tears it
that
down.
controller.
Mm-hmm,
It
mm-hmm.
throws it away. And then if a new request comes in, it instantiates a new controller. So you can shove a controller is just an object. So you can shove instance variables on that object. And you know that those, whatever you put in the instance variables there, are only going to be used during the request for
Gotcha.
that one request you're handling. And it's not going to leak. It's not going to be long lived. And the React cache is very, very similar to that, where it is only going to be used for the request. And you kind of teed this up nicely with the current user, but why would you like? What is the point of a cache that only lives for, let's say, 50 milliseconds, that only
Right.
lives for the life cycle of the request? And so imagine you have a page, and that page renders two components. We'll call it like component A and component B. And inside component A, you fetch the current user and you print a message that says like, hello, first name, hello, Bob. And then inside component B, you fetch the user and you say, hello again, Bob. Both of those components render, component A and component B render. They both make a request to fetch the user. Let's just say it's fetching from, I don't know, it uses like a
Prisma.
cookie, and then it goes and looks up that session data in a database. So there's like some latency, some external system that it needs to talk to. So component A has to make the request to the database, and component B has to make the request to the database. And so now you're looking at that and you're like, well, this is silly. I'm making two requests to just render this tree. Why don't I hoist the data fetching up into the page? I'm going to fetch a current user in the page, and then I'm going to pass in, component A, user equals user I just fetched. Component B, user equals user I just fetched. There's only one data fetch. That's kind of like how we would like kind of introduce, what do you call it? Lowest common ancestor
Right. Exactly.
state
Yep.
in React. We kind of
Yep.
hoist it up.
You hoist it up and then they become dumb components or whatever. They take in their data. It's like my talk
Right.
from Next, where instead of fetching its own data, it takes in its data as a prop, and
Exactly.
the reason you're doing that is for an optimization so that you don't um, you don't have the two requests going out. Yeah.
Right, exactly. You don't have the two requests. You might look at that and say, okay, yeah, this is good optimization, right? We can do this. But this gets a little tricky because um, let's say you have a layout, and in the header, the layout renders a header. The header says like, hello, first name, hello, Bob. And so the layout needs to fetch the current user. So it makes a request to fetch current user. And then your page makes a request to fetch current user so it can share that data with component A and component B. So now you have these two separate React components, and the way that layouts get their page that they're going to render, they get it passed in as children. So you don't really have a good place to, you don't really have an intuitive place where you can pass in props. Maybe you can do like something with like clone element and like sneak some props in there, but like that stuff's just like a foot gun. Like you get children and you render children in a layout, so you don't have a good place to just pass props around. So you run into this problem where you have your layout and your page are both making database requests, and there's no real place to hoist that data up.
So
And
even
so
though
this
the
is where,
layout is conceptually like become the lowest common ancestor because conceptually the layout sits above the page. So if you were following that rule of state hoisting, basically, that's what I was thinking. Like state hoisting, you learn about that when you're doing React state, but it's the same idea here. There you do it for so there's a single source of truth. Here you're doing it to optimize performance and avoid unnecessary database calls, but the concept is the same. So if the layout becomes lowest common ancestor in Next, there's no good way to just pass that as props. But even in other systems, you can imagine this hoisting to the LCA over and over time for
yeah.
something that's really global, like a current user, could be problematic, even if you were using a framework that lets you pass props from the layout to the page.
Yeah, yeah, and of course, like you could do like maybe there's like frameworks with outlets, and
Right.
like outlets have the ability to take props and then forward them onto their pages. So like there are creative ways to
Right.
solve this, but let's just like we'll just look at
Yep.
next. Next takes
Next. Yep.
children. You have no good way to pass props, and so this is where cache can come in here really helpful. You have one function that you call that's called like fetch current user, and fetch current user, you wrap it in React Cache. So React Cache is a function that takes a function and returns a new function. That new function is going to be a memoized version of the function you passed in. And so now every time you call load user, the first time you call it, it's going to run the function and return a promise because you're fetching a user, you have an async function. The next time you run the function, it's going to just reuse that promise. It's not going to go off and rerun the function. It's going to say, I see you've already called this function. I'm just going to give you back the promise from the first invocation.
Nice. And
And
the
so
promise is already resolved. So, but it's still a promise. So it's a venable, but it's basically fulfilled. And so it's not going to take any.
it doesn't necessarily have to be fulfilled. So it
Ah,
could be a
ah, 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 ah.
long-lived promise, and you're just going to get back the
Ah, the
thing,
same promise.
the same promise that the first invocation called.
Got you.
So let's say layout calls get current user, and then your page calls get current user. And let's say get current user just takes 5 seconds to
Mm-hmm.
fetch the current user. Well, both of them are just going to be waiting on that same promise.
Mm-hmm.
So it's only going to take 5 seconds.
Mm-hmm. Mm-hmm.
Um,
Mm-hmm.
you could imagine if this took 5 seconds and they were using different promises. Well, first your layout would render,
Mm-hmm.
wait 5 seconds, and then your page would render, wait 5 seconds. And this is where like the waterfall from RSC starts to come in.
Mm-hmm.
But with cache, we're going to get back that same promise. So we only ever wait 5 seconds.
Cool. Very
And
cool.
yeah, the really cool thing too is we can go back to, remember in page, we had like component A and component B. We can go back into component A, component B, have them each fetch their own data. So each of them can fetch a current user. We don't have to hoist it up to the page component. And they're just going to use that cache version. So you don't actually pay a penalty for components having to fetch their own data. And you don't pay a penalty for components that have to fetch repetitive data or repeat fetches to the same resource, which is awesome.
Cool.
Which is awesome because data colocation in components is like one of the most beautiful things of RSC.
Cool. Okay, I have several questions.
Yeah.
So first, yeah, it's nice because even though hoisting the data up to the route solves the problem when you're when you're first coding it, what happens when we coded Ember or Rails or anything that does this is exactly like you said. You disconnect the data from the components that need it, and there's no more explicit dependency. It's an implicit dependency. Now, you could update component B. You update it to take in current user as a prop, so you know it needs it. And you might say, well, that's a dependency right there. Isn't it clear? But what about when you delete component B from the page? The reason you are passing it from the route, from the layout to the page, or from the page to middleman component, was for component B. But now you've deleted it. You get no feedback that you could actually remove the current user fetch from the route level. So I think that's,
and move it back into
and move it
component
back
A.
exactly. So that I think is an awesome story. And when routes do overfetching after refactoring, or it's just not clear because now the route has the data that for every component in the page, I think the colocation is a really nice principle. So what was that term that it's like not separation of concerns, but the opposite? It's like
Locality of behavior.
locality of behavior. Exactly. So I think that's a huge benefit for sure. Next question is, it returns the promise, but I'm guessing the cache from React returns whatever the function returns. So it doesn't have to be a promise.
Yes.
It doesn't have to be. It doesn't have to be anything.
You're most likely you're going to want to cache things that take time so that you can reuse them over and over again without paying that time cost. So the two examples here are going to be anything with IO. So that's going to be a promise, data fetch, anything async. I guess the other example that would fall in this category would be
CPU bound
calculations.
Right.
What? Yeah, something that's CPU bound. So maybe you're fetching a bunch of data from a database and then you're doing a whole bunch of, I don't know, math on it. I don't know, something slow. Something that's not async, but it's slow.
You're finding the 100th element of the Fibonacci sequence or something, and
Yeah.
both these components need it.
Now this is kind of interesting because for that sort of thing, you actually would want a durable cache, right? Like you would want a durable cache because remember, this cache only lives for the lifecycle of the request. And so if every request had to pay the cost of finding the 100th Fibonacci number, then every request is going to be slow. But you could do that work ahead of time, throw it in something like Redis, durable cache, without getting an implementation. Just put it in a durable cache.
But you could imagine some expensive CPU bound computation that also is dependent on the user, right? So that's specific to the user. So this would again let you keep the code, the locality of behavior for the thing that's CPU bound. Now, I guess in the event of something that's truly like blocking the CPU, it's gonna block execution. So if you start running a function and there's no way to batch or pause it, the first time it's called, it's just gonna take that time, but then it'll be cached. So you'll never have a situation where two components have kicked off the same thing. Component A renders and it starts making that calculation, finding the 500th prime number, and then component B has also kicked it off, but it gets something like a promise to say it's already in progress. You would just wait for that. But the point being, if you got later to that and you ran it again, the cache function would just know that it had already returned, and so it returns the result.
Yeah, you would. Yes, exactly.
But network bound is the common thing here, as opposed to being CPU bound for stuff like this. And because of network IO being asynchronous in the event loop in JavaScript, you can be rendering N components that all reference the same thing, and the promise returns immediately from the cache, and so they'll all be waiting on the same thing.
Also, just like in sort of how you build web apps, like how web apps are traditionally built, they are not high CPU intensive.
Right.
If there was like a high CPU intensive thing, you put it in a database,
job,
in a view, cache. So it is mostly going to be network. At least in my experience, why I reach for these things is because I want to be able to fetch a current user, but I don't want every single component to have to pay the price of that.
Right.
So one example I gave here was the fetching data in both a layout and a page, and how there's no good way to like thread props through there. So you'd want to reach for something like cache. The other example is just, look, we can talk about data hoisting and why you should hoist data up to the lowest common ancestor, but in complex React applications, there can be like 15 different levels of components. And if you have to hoist data all the way up, now you're just prop drilling. So you're just passing a prop all the way down through this like 15 component tree just because the first component and the 15th component happen to need the same piece of data. And so like, components 2 through 14 are just like, hey, I'm receiving this prop and I'm not using it. I'm just passing it along. And that makes code really, really hard to refactor. And
And
so
then people reach for
even if you
context to
could,
solve that problem.
right. So could, even if you could prop drill, it can still create problems making code hard. And like just kind of as proof of this, in client side React, we have solutions for this. And as you just said, there's context. You can go use context in client side React to basically share one piece of data with two components that are far away. And when I say context, we have React context. We also have these like global
Stores.
use global store. These like external stores they're called in React. So like use global store, zoo stand, just a whole bunch of libraries that are kind of help with managing this state. But in server components, in React server components, we don't have context. There's no context in React server components. So you can kind of think of cache as a way to get that context like behavior when you need to share data amongst multiple components, but you only want to do the work once. And actually, just like it is really common for client-side React apps to reach for these things. Like any data fetching library, like SWR, Apollo, is all going to have something like that implemented inside of it. You as a user aren't like wiring that up, but that's like how those libraries work. They want one place to coordinate the fetch for their data, and then be able to share it with multiple components.
Even
And you can think about it, like cache is just like that. It's like one place to coordinate the fetch, share it with multiple components.
Yep. And even like Shad CNUI has a store that's external for storing things like, the state of a UI component that it can share with all the descendants, all of its children, without having to prop drill. And, use sync external store function that made it into React 18, I think, is like the official way. All these things now interact with that. So context for sharing state without prop drilling is a React feature because changes to those context values should trigger re-renders. And so usually you have state in context. I remember when context came out, people were passing not state. They were just passing data among a bunch of components as props, like colors, like a color scale that doesn't ever change. It's part of your design system. And you define it here, and maybe you define it as a variable in the React component, and you want your child to have it too, so you start passing it through. But that doesn't change, and so it's not React state. So that could just be in module scope and imported. You don't need to be participating in React rendering to do this. Go ahead.
That is a great point. Let's talk about why module scope is dangerous on the server.
Yes. So that was my question, because the reason we don't have, and correct me if I'm wrong, the reason we don't have context on the server is because you don't have state. You do not have React state. So it doesn't really make sense for React to have a feature like context on the server. And people are used to using context for sharing sometimes data that is not state. And then they try to do this on the server, and they're like, well, I have a connection to a database that I want to reuse. Why can't I put it in context and like use Prisma, use DB everywhere and just have it? But that's really the problem that this is solving in terms of memoizing. You want to memoize that, or it has nothing to do with rendering, is what I'm saying. It has nothing to do with state triggering re-renders, which is really what is part of why context exists.
What context? Yeah. So let's take a trip down a memory lane here. So in the early days of RSC, there was a server context, and it was meant to basically do this thing to share data, so multiple components wouldn't have to do the work. I actually believe that's still in RSC, but it's deprecated. You get a warning if you try to access it. I think some code paths have been removed. I'm not sure, but I know it's deprecated and you're not supposed to use it. The reason you're not supposed to use it is because cache, as coupled, or I guess cache as well as module scope, can solve all these problems. So let's talk about why you wouldn't want to use module scope. Let's say we're going to put colors, like theme colors in module scope. They don't change. Like there's no re-renders, but we're just going to set them in module scope, and any component can like import them from a different module if I need the color. The problem with that is that data, that module, is shared. It's on your server. So it's shared with every single request that comes into your server. So if you put any user specific data into module scope and another request comes in at the same time, and those requests are being processed in parallel, a request from user A comes in and it writes data to modules. It puts like the current colors in module scope. And then at the same time, a request from user B comes in and writes data to module scope. It overwrites that data. Now user A can start reading user B's data in module scope. This is never a problem in client-side React because the client-side React app is only running on the user's browser. It's only running in the user's browser. So if you write data to module scope, yeah, it's only on your computer. My computer doesn't have access to your memory in Chrome, but in a server, it is a shared environment. There's multiple requests coming in. They're being processed in parallel. So if you use module scope, you basically have to, you're in a really tough spot because you have to have a way that's like locked for certain requests and it doesn't leak across certain requests. And it's really, really easy to make a mistake here, especially if you're putting user-sensitive information in module scope, because as soon as you start processing requests in parallel, which all these HTTP servers are going to do, you just run the chance of leaking data. So cache is per request, so it won't leak its data. It's per request, so every request gets its own cache bucket.
Let's finish the story. So because of the problem you just said, is that why server context has basically was removed or deprecated? Is because of what you just said?
Server context was removed because anything you needed server context for, you could do in either module scope or using the cache helper.
Okay, got you. And then the story you just explained is why you wouldn't use you shouldn't use module scope for certain class of things that are related to specific requests.
If module scope is great for things that are the same for every user. So things like env variables, those are going to be the same for everyone. Maybe you have like some global theme that's the same for everyone. Module scope is perfect for that. So just use module scope. Things that are dependent on the request, dependent on the user, you want to use cache for. You basically want a guaranteed place to be able to read and write data from, but it doesn't ever leak out or it doesn't ever go outside of the request.
Gotcha.
Just kind of like side note, cache in React, this is an implementation detail, but cache in React is implemented with AsyncLocalStorage. And AsyncLocalStorage is the worst name ever because when you think of AsyncLocalStorage, you think of like, oh, it's like local storage, but it's asynchronous. Maybe like there's some way to get there, but it's nothing like that.
Is that a Node API? So it's a Node API?
It is a Node API. Yep. Yeah. I think there's like some history for the name, and you can kind of like work through why it's like use client. You know, it makes sense when you understand everything.
Yeah.
AsyncLocalStorage basically lets you kick off a series of asynchronous steps. So like await A, await B, await C, and guarantee that all of those awaits can share a piece of memory. So you can, it parallels really nicely to React context, but it's a Node API.
Interesting.
And so this is one of the reasons why you don't need server context, because
interesting.
you can use async local storage. So I can start a new async local storage run. I can start two async local storage runs at the same time. Each of them are going to like await A, await B, await C, and they will have their own place to share memory between their awaits. Where if you just did module scope for that, each of those
will it close over different variables or something? Or
they would be overwriting module scope.
So, got you. Okay.
So like await A can put something in the async local store, and then await B can read from it, but it's only ever guaranteed to be in like that you can think of it like function stack. It's only ever guaranteed to be read from those functions. If I start a new async local storage run and it has await A, await B, await C, await A can put something in the store, and only the await B that follows it can access it.
Interesting.
So you can serve multiple renders. You can serve multiple requests in parallel and guarantee that those requests have their own like private little place where they can
Interesting.
store and read data from. And so that's how cache is implemented.
Oh,
So it
okay.
uses async local storage, which when you look at async local storage and you actually look at the APIs, you're like, the best mental mapping is it's React context. It's the same sort of idea. You have
Okay,
like,
so this interesting. Okay, so this I had some more questions, and one of my next question was going to be thinking about component A and component B doing the get current user. I get if you say fetch current user, get current user is a function wrapped in React cache, and it just returns a promise, and so because that resolves immediately, um, the promise is put into React cache, and when component B attempts to render, it's just going to get that immediately. And so they're both awaiting on the same thing. And so now, you know, they suspend, let's say, and then when the promise resolves, suspense knows to re-render them. They're both going to be looking at this point, is it the promise in cache, or is it like React has put it somewhere so they can attempt to I guess they'll just point back to it. And anyways, whatever happens there, there's like it's conceptually makes sense. There's like a single promise that just ends up somewhere and both things point to it. What I was going to ask is, what if the get user function is like more complicated? It doesn't do a single fetch, or it doesn't just do a series of awaits, which is still going to resolve a promise immediately and then wait for those things. Yeah, what if it has like uh like a module scope. It has like a variable that it references an object maybe above it. It's closed over it. You await the fetch to current user. You set the user to that or something, and then you do another wait to check if they're an admin with your permission system, and then you update that. And now that it's not returning like a simple promise, or something could happen where that function is not so simple, but they're both trying to do things. So you have component A and component B who are doing this thing, but like they didn't get the same reference to something. Is that not possible, or is that like you're violating the rules of cache because you can't reference or close over the external variables? Um,
yeah, those are great questions. There's two questions there. So the first is like, as soon as you reference module scope, that's shared memory amongst all of your requests. So if you ever put anything in module scope, you are running the risk of another request, like other requests can read that. If other requests do read that, I can't tell you, like I have to look at your code, but as soon as you put something in module scope, like you are
you broke
saying
the
like,
contract in terms.
yeah,
They can't make any
it's just
guarantees.
danger. It's like,
In the same way that if you put, like I plus plus every time you render, Rack can't guarantee what I is going to be in your JSX because you're just doing plus plus somewhere or something like that.
yeah. The scary thing why some of this doesn't map well to browser-based React is because browser-based React, you own your environment. You
Yeah.
can't leak stuff out of your
Yeah. Yeah.
environment.
Yeah.
My computer
Right.
can't access your
Right.
computer.
Right.
But with the server, as soon as you go into module scope, then any other requests that your server is processing could potentially read that module scope. So like that's something like that's important to understand. And so you do want to stay within cache if it's like user sensitive information. Maybe you do want to fetch data and put it in module scope, but it's safe because it's
Right.
shared for every
Right.
request.
Right.
The deployed version of my app, or
Right.
the
Right.
get SHA that I've deployed, like, something like that.
The
So
newest
that's
Build Dry
one
video.
answer for like, what?
The newest build dry video. It's not specific. It's not. It doesn't depend on the user.
Right. We would use by the way, module cache is durable cache if you are dealing with like a long running node process.
That's what I was also
And
going to ask. Is that like when you're talking about per request, and like if you think about serverless or something like that in your mind, you might think like, oh yeah, everything is happening in separate places. But like you were saying, most HTTP servers, you run npm run start the same way you run npm run build, and that server is handling multiple requests and could be doing them in parallel.
right.
And so there's a single environment with memory that could be changing, and that code could be referencing. So that's the problem there.
And even with serverless processes, like some serverless things will say, we will use the memory. We can reuse memory. Like it's not guaranteed that every single request that comes in is going to have a clean slate of memory.
Right. Makes sense.
Most of them do, but
You
there are
can't. That's not something
situations
you
where
can. You can't rely on that. You can't say each
exactly.
thing is a black box or a firewalled off from each other. So, okay. So
I think that's a good way to look at module scope. So what's the difference between module scope and React cache? React cache is per request. Module scope is durable. So module scope is more similar to something like Redis or Memcache or database or some external store.
cool.
Durable cache.
Perfect.
Okay, so that was your first question of like
Yeah.
accessing module scope. What was you had another question?
So the second
on
one
that.
is like they're both the get current user is doing like it's doing a
yes.
set of things, and that's what made me think about it was the async local storage. So
The first time you call cache, like you are going to get back, you are either like your cache thing is going to be a synchronous function. So you're just going to get back a result right away. Now that result might be the next thing that happens in the computer. It might take time, like finding the
right.
Fibonacci sequence. It might take
Right.
time, but the computer isn't going to be able to do anything else
right.
while it's processing that. Or you get back a promise. So right away when you call cache, as soon as like that function ends, you have something that's cacheable.
I
So
see.
any future call to that function is going to just use that same value.
The return
So
value.
you're
Whatever the return value is.
Yep. Now I don't know, like you could probably do something like you could probably get into trouble where if like you cached a function, called it, got its return value, then modified its return value.
Yeah.
I don't know. Like I haven't experimented that. I don't
Right.
know. Like that to me feels wrong.
If you return,
like that
if you
to me feels
return,
like some.
if you return an object and it's a reference to an object, it's not like a copy of it or whatever. It's an object,
So
and
I
then
don't-
someone
yeah, I
mutates
don't
that
know.
afterwards.
And then like what? And they like mutate it, but like there might be like a race condition with the
Right.
mutation. So like
Right.
sometimes
Right.
another component, like there's like let's say server A or component A kicks off the cache, server B reads from the cache and mutates the cache, and then server C reads from the cache.
Right.
Depending
Component
on
C,
like
yeah.
when B and C run, what's that? But again, I would look at that code and I would say like this is wrong. This is not like within the spirit of how it's supposed to be
You
used.
can't.
If
It's
need
you
to-
can't guarantee the behavior when you're doing something like that, and for the same reason, you can't guarantee React can't guarantee no tearing if you're doing side effects during render, something
Yeah.
like that. Yeah.
Yeah. Yep. That's a great yes. Yep. Cool. Just there's a few more things I want to just like button up here, and then I want to get on to like a really cool use case for this.
Okay, I have like one more. I have
yeah,
like
keep going,
one.
keep going.
Okay, so given that the function that you cache has to return before it's either going to return if it's going to take a while if it's CPU bound, or it's going to return immediately with a promise, which means when the component B tries to render, it gets the promise, and then they're both going to get the return value when the wait is done, when the promise resolves. Why async local storage is needed? Why do you need that at all? Because I don't understand why you would need the ability to run two functions and like make sure they are firewalled from each other if all we're doing is waiting for the first time the function is run to complete and then taking the resolve value and then returning that everywhere else. So the idea of like yeah, go ahead.
Yeah, we need to stash that value somewhere because a React server component could take time to render. So there could just be a whole bunch of suspense boundaries,
Okay.
a whole bunch of other async. So if
Okay.
I in like my layout, if I call load current user, and then like I have a whole React tree that also calls load current user, like those things might not happen one after each other. There might be suspense boundaries,
Okay.
and just long running stuff. So I need to stash that value somewhere.
And you don't want to
while that
stash it
value
on
is
module
stashed,
scope because it's
other requests
durable.
could be coming in. Yes.
Okay.
Well, just you don't want to put it on module scope because other requests could be coming in, and I don't want those other requests to read the current user on module scope because those will have a different current user. So this is where
right. Okay,
this
got
is the
you.
whole idea of async local storage. You have a async function stack of functions that call functions that call functions, and they need to be able to reference a value that is, and then you can kick off another async function stack, and it needs to be able to reference its own values that came while its async functions run. I'm probably doing a bad job.
No. I
explaining
think
it,
I understand. The two stacks of async functions that are running using async local storage are from two requests, not from component
Yes.
A and B. Okay, that's what I was missing. That's what I was missing. And you could imagine if you were implementing this yourself without async local storage, and you were implementing React Cache, you would have to come up with some way to say this is coming from this request ID, and so it can be shared among everybody who makes the same call to get current user here, as long as the cache key would also depend on the request somehow. This basically
Something like that,
sidesteps
yeah.
all that.
It's a little side note here in the Node.js docs where they're talking about async local storage and why you would want this. They do have a line that says something like, "You could implement this yourself, but you'll probably make a mistake, so don't do it." And they
Yeah.
don't even like describe like
Perfect.
how to do it.
I love
They're
it.
just like, "But it's really hard, and you're going to make a mistake, so don't do it."
Cool. Okay, cool. And then my last question before you get to the tidbit you want to button up with, because that all makes sense now, and why you have module scope for durable shared memory place. You have React Cache, which is using async local storage for non-durable request specific place to put things that you want to cache so that you can use it again, memo-wise, basically. Same as what you would think of as memoization in like a Rails app. My last question from the initial thing was, why is this part of React? And maybe that's also part of the answer, which is like using the async local storage API is cumbersome, and they think this is an important part of the programming model, so it's a React import, but it has nothing to do with React, really. Except that it enables
Yeah,
this model of composition, so it's just like a key part of it, like the
you,
colocation.
you know that is a great question, and I would actually love to like explore that with people that are on the React team. I've noticed with React server components, there's other APIs that fall into this category where it's like, oh, I could do this myself, but it's really cool that React provides this for me, so I don't have to think about it. But
For
another example
example,
is React has this idea of like asset loading. So if you load a style tag, like let's say you render a component that has a link attribute that's like a CSS file. It's a link tag
a link tag.
with a to a CSS file. Like React would draw those pixels on the screen, and then the browser would go off and fetch the CSS file. So there's like a time where you have the HTML rendered on the screen, but the CSS hasn't loaded yet. So this is like you get like the Times New Roman, and then
Yeah.
you go off, CSS comes in, and then it's like a beautiful looking website. So React actually is aware of this, and they say, well, if you render a link tag, you can give it this thing called precedence, this attribute. You can render a link tag, and React will actually suspend. It won't draw the pixels on the screen until you go off and fetch the style sheet, and then it
Interesting.
comes back, it unsuspends. So you never get like that inconsistent CSS hasn't loaded paint, which
Flash
is what we,
unstyled, the original Flash of unstyled
yeah,
content.
the original,
Literally, it's
yes.
unstyled content.
Yeah.
Yeah.
Yeah, the original Flash of unstyled content.
Uh,
Now, like you could implement that yourself, right? You
yeah.
could write your own component called like capital S style sheet that suspended, went off and did a link thing, had an effect that like put it in head, used like on load to unsuspend. It would be a lot of work, right? Like, but you could do it yourself. You could do that in userland. But the fact is that React has this built in. And so like a question that I have is like, is this more of a convenience? Are these APIs more convenience, or are they like, no, there's actually like a whole bunch of tricky stuff that if you try to start implement yourself, you're just going to like spend all this time. And it's like so much easier for us to implement it at this layer of abstraction.
Right. Interesting. That's such an interest. The precedence thing is very interesting because it's almost the same as data loading. Like you you're loading an asset, right? And you're like, well, data loading. Oh yeah, that's not React's job. Like React is about render, which is like
Yes.
reconciliation and commit, and so it needs to have a sense of state and a data flow of state that includes objects and functions and when to re-render things. And then context makes sense to be a React feature because you might want to update certain parts. And so all those things feel related to the core, value proposition of React, which is like the rendering model. But then but then you say, oh, asset loading, it's like important enough, so we have this. And then you say, yeah, data loading is not core to that, which is why we have 10 different ways to fetch data in React. But now with server components, it's kind of expanding the horizon of React's concerns, and there are ways in which it is integrated into what eventually becomes React rendering and reconciliation and commit, that it can be done in a better way, in a way that encourages a certain kind of programming model than if they didn't do it, right? And so that's pretty interesting, because you could argue, if someone was arguing, yeah, it's not really React's responsibility, someone could say that about data fetching, and we would have said, yeah, of course not. Next has get server side props, and Remix has loaders, or you can make an SPA with use SWR, so it's good. But then it's like, well, now we have RSC, and that's even better, because we're going to be able to share data fetching components in a way we've never done before. You could imagine them continuing to do this and having an image tag render that suspends while it's loading its image. And we always thought about that as something like, oh, that is the job of a framework like Next, where you have Next image, and this is so cool because it does all this stuff, and maybe there's a framework that has its own version of image that suspends until it loads so that it can coordinate and you don't have to wait. But you can imagine one day React adding this for all such components and elements that involve different states, So that's pretty interesting.
Yeah, I think my question, and like why I'm kind of like unable to answer your original question, is I don't know where the line gets drawn in terms of like, no, for image tag we want the frameworks to implement that. There's like enough like just like responsive images and image CDNs where it's like we don't want to deal with that. It makes our API surface
I
area
think it'd be
too
awesome
big.
if React had an image tag that's
I know,
suspended.
but you and I, of course, would think that, because we're convention,
Right.
We love frameworks, but
Right.
I remember Taylor. We were in a group and someone asked Taylor. He said someone asked Taylor, when do you add things to a framework? Like when do you add things to Laravel?
Yeah.
If someone just opens a PR adding a feature, how do you know if that's good or not? And he had a really good answer. He said that, he wants people to be able to do things in user space. So if someone opens a PR for a feature that could be done in user space, he's not going to add it. Now, I'm sure there's obviously there's conventions that are so important that he'll add, but just for random PRs. And I thought that was I was like, man, that's a really good take.
It's a good answer.
Sets up a nice little boundary.
Little rule. And it's different from, DHH is going to add 4.hours, because even though you can do that in user space, he's optimizing for what his style and, eloquent writing and all that stuff. There's a little bit of a tension there, but
well, it might just be if someone opened a PR that added 4.hours, DHH might say, no, you can do this on your own. I don't need to add
you
this.
Can make that. Okay, got you. I see.
Where you as a framework author can say, I'm actually going to take the time, or my team's going to take the time to add 4.hours because I think it's so beneficial.
But I think the server components do something that you can't do in user land, right? And so maybe the asset loading has some aspect of that too. Or maybe it's mostly convenience and it's hard to do, so we want it, but it probably integrates in a way that there's something that, because I see React as
my guess
philosophy.
is it's right. My guess is it matters and it has to be done at that layer of abstraction.
Yeah.
I just can't tell you why.
Yeah. Cool. Okay, go ahead.
Okay, so you asked in the beginning about I think you asked about client side React.
Yeah.
Something like that. Did you ask about that? I don't know. You said this was only for server components.
Yeah.
Yes. So there was a cache that behaved like this with client components, but that has since been reverted. So if you import cache, you can still import cache in a client component. And if you cache a function, it just returns a function that is your original function. It doesn't actually memorize the function.
Identity function, basically?
Yeah, basically. I mean, basically, yes. It's a no-op. So if you cache load user, it's just going to return load user to you.
Okay.
Yeah, identity function, right? Mm-hmm. And the reasoning for this is that the client-side app is long-lived, right? Mm-hmm. So that is an app that is, can exist for weeks or hours. And so caching becomes it's tricky. It's super. It's
one of the two hard problems. It's not hard when you get to hit reload every 40 milliseconds, every 100 milliseconds, every link click.
When your cache is only alive for the lifecycle of a request. So it's maybe only alive, like I was saying, 40 milliseconds, maybe 100 milliseconds. You don't really have to deal with like cache invalidation.
Right.
There's like just a lot you can just this isn't a problem. It's gone in 100 milliseconds. But on the client, that's not the case. It could be there
Yeah.
for hours or
Yeah.
days,
Weeks. Yeah.
and you do have to deal with invalidation
Yeah.
probably.
Yeah.
And so the React team has said that this is something they do want to think about and maybe add in the future. But right now, this is specifically for server components.
Okay,
The memoization behavior exists only in server components. You can still use cache on the client, so you can still have a component that works in both environments, but on the client, it's not actually going to be memoized.
Okay, that also clears a lot up because I was going to ask about invalidation, and React Cache on the server has no API for it.
So there's a bunch of like React DOM server packages that are going to implement this, and those packages, like they're like React DOM server Webpack. They are like the bundler integration packages, and they actually, I'm not sure. I think that's the case. I'm not exactly sure about that though. But they do not. The React DOM server Webpack one that I'm using does not have any concept of invalidation. And
The only API is
I
you
don't
put
think
the function in and it returns it, and that's it. And because we're
Right.
in the constraint of a HTTP request response cycle, it can be that simple. It can be boiled down to that.
Yeah. And even in Rails, when you did this in Rails, Rails had a few of these request caches. You mentioned one with current user. It was really common for people to do. People also did it with SQL queries. So SQL queries would be cached, but they would only be cached for the lifecycle of that request.
Right.
So if you ran if you had a view, multiple views that kept rerunning the same SQL query, it would just always get the same thing. You never needed to invalidate those
Right.
because again, they're so short-lived.
Right.
Isn't like it's so funny, man. The length of the time a cache lives, it's like that complexity just like grows.
It's
you
not
know?
just a change in degree; it's a change of kind, right? Because
Yeah.
and also this is why I think you or others have also said it really does feel more like a memoize as opposed to cache, because cache, what are the fundamental, aspects that make something a cache? It's like put and get and expire,
Yep.
like and delete. So you're never
Yep.
really deleting
yeah,
it
a
here.
memcache API. Yep.
Yeah. Mm-hmm.
And also too, just you're most likely using these APIs with Next.js.
Right.
And Next.js is a framework that like caching is a core part of the
Right.
framework.
Right.
Like it is
Right.
not a framework where caching is optional. It is a framework that is built around
It's
taking
embraced.
advantage of
Right.
caching. Yeah,
Right.
it's embraced.
Right.
Exactly.
And
So it
and
can
this is also
sometimes be
why
hard to
you
separate the two.
right. That's also why you said that, which is that it's the React cache is solving a completely different problem, and it's a completely different tool than when we talk about all the layers of caching in a framework like Next, which we're not going to get to today because we're already at 54 minutes. But we'll have to talk about Next caching next time. But go ahead.
Cool. I have one more kind of awesome example that this unlocks.
Let's do it.
And so we kind of talked about we have one function, load current user, and all of these components we're rendering layouts, component A, component B, they all want access to it. So one can kick it off and they can all read from the cache. But oftentimes, like in React, like we have multiple different data fetching calls. And there's this idea in RSC, this like scary idea of these waterfalls. So imagine we're building like a news site or content site, and I have to go fetch a current user, and then I have to go fetch their membership level. Their membership level is either they're like a free account or they're a premium user, something like that. And then I say if they're a premium user, I'm going to render this component called like premium articles or premium content. And that like just, and then the premium articles component,
Fetches.
that thing goes off and fetches the premium articles.
Right.
So just like describing this situation, you have an inherent waterfall. And a lot of people will look at RSC and say like, this is bad, this waterfalls, and the waterfall here is that data fetching is tied to rendering. And an example of this, data fetching is tied to rendering in the premium articles component. And so you can't start fetching the premium articles until you
You know
render
whether
premium
the
articles.
use right and right.
And you don't render
Can't render
premium
them until you
articles.
know whether the user is a subscriber or not.
Yeah. And so what this causes people to do is they come up with like all sorts of clever ways around this. You remove the data fetching of premium articles outside of the premium articles component, and you hoist it up and you fetch it while you're fetching the membership status. And then you like pass the premium articles into the premium articles component. Like we said before, kind of how we kicked off this podcast. But like that, like, is that good? Like now you like we
You've
said
broken the
before, like,
locality of behavior, and
yeah,
if you change
the
it, you don't
component
know
is no
why it's
longer
there.
fetching its own data. It's like
Mm-hmm.
this thing is all the way over here. Why is it over here? Because we don't want it to waterfall. It's like that's a crappy reason. Like
Mm-hmm.
it's just a crappy reason.
Yep.
So cache really nicely solves this problem, because what you can do is you can your data fetch, your function that fetches the premium articles, you can wrap in cache. So we have this cached function called load premium articles, and we're going to call that in our premium articles component. And when we call it in our premium articles component, we need to await it. So we're going to do like let articles equal await load premium articles, and then we loop over them and we render them. In our page component, when we're fetching the membership status, we can also call that cache function, but we don't need to await it. So it's going to look like load premium articles,
Oh, okay.
semicolon,
Okay.
await load membership status. And both of those two data fetches, they kick off at the same time. They kick
It's
off at the exact
you're
same time.
prefetching it. You're just prefetching
You're
it. But
preloading.
because the cache returns the same promise, it's the same situation as if A and B were rendering together. A's already kicked it off, and B is just getting a reference to it. Okay.
Exactly.
Wow.
So, and then let's say the membership isn't premium. Like you actually get the user's membership status back and it's free. And so you never end up rendering that premium articles component.
Right, and you're on
Well,
the server,
you're
and
not
you
awaiting.
don't share that data, even if it's private data. It doesn't end up in the client app at all because the server is just returning the JSX, and so it doesn't matter if you did that.
Exactly. And like you're not awaiting the load for premium articles. You're just kicking it off
Right.
so that if premium
Wow.
articles component needs to fetch it, it can await it, but you are
Wow.
not awaiting it.
Wait,
So
that's
all
badass,
you
dude.
so all you've done here is you've made an unnecessary call to your database or
Right.
an unnecessary call to your CMS, but like you
If you
get
have
to
an
avoid the
inherent
waterfall.
if you have an inherent
And you
waterfall and you can't avoid that, that's the only thing you could do to speed it up if it was a problem. Even if you were in Rails land or something like that.
exactly. This is a key point. If someone says like, well, that's crappy because I had to make an unnecessary database request and I never use that data. Well, then based on that description, you need to waterfall.
Right,
Because you can
exactly.
only fetch data if you know you
Exactly.
need it. And no matter what, this is not a React thing. It's not a React server component thing. It's not even a JavaScript. It's just a general programming thing. If you
Yeah,
need to
totally.
waterfall, if you need to not make unnecessary requests, no matter what you're writing in,
Yes.
you need to waterfall.
Yeah.
But if you want to avoid waterfalls, you can go ahead and you can use not await the function, kick it off, call it, get that data in the cache, so that if a component happens to render, you can go ahead and have that data loaded by the time it renders, or just kind of pre-start it,
Wait,
preload it.
this is so cool.
And two, you are like in a sense, you're not hoisting the data fetching.
Yeah,
You're just calling
Yeah.
load premium articles. So that the idea of what load premium articles does, what systems it talks to, that's still hidden inside that
Exactly.
data fetching function.
So
Very cool.
Very cool. So okay, so many thoughts. This is really interesting. First, I like that it's a way to solve this problem. Let's say you weren't in a inherent waterfall situation, but you just because of rendering and suspense boundaries, you kind of get like a waterfall that could be avoided if you had hoisted it to the route.
Yep.
This is a way, like you said, to leave it in the component so you have locality behavior. If you ever want to change that function, you change it down there. But you're just preloading it. You're kicking it off. Preload, right? Because I'm probably going to be rendering this homepage bookshelf of videos. And so I want it to be ready in case we do, which we do most of the time. Now, if you delete, and because you're not awaiting it. So this is why it's better. Let's say you didn't have a waterfall situation. Because you're not awaiting it in the route, then it doesn't slow down rendering of the route. In the event that you, let's say you refactor and you delete the bookshelf of videos or whatever, and you forget to remove that call from your route, it's not slowing it down.
Exactly.
It's not slowing it
I guess
down.
you are like, in a sense, you are like, your server is
Your
doing
server's using more
work,
resources that are unnecessary. So there could still be like some way. I was trying to think if there's some way if you do that refactor
yeah, you get
that you would know
like
to clear the
alerting.
code, that you don't need to
Yep.
preload it because nothing in the tree is ever using it, something like that.
Yep.
But anyways, it's a really cool middle ground between hoisting and passing as props versus
That was
that's
exactly, so
awesome.
when this started to click for me, that it was exactly that. It's not
It's
just
defer.
hoist.
Remix has defer, which does essentially the same thing. It doesn't block, the route doesn't block on it, but it's a way to kick it off as at the entry point of the route. But then you pass it down. This is like it's like that, except
Yeah.
except they're pointing the same thing. I guess the one downside is, let's say you had an async component, RSC, that was fetching the premium articles down here, and then you want to kick it off, and you would have to extract the query into a place that could be imported. I guess that's how you would do it.
Yes.
Your
Well,
component
well,
could
just
export your component could export the function
yes.
so that anybody could call preload on it if they wanted to do it ahead of time.
Yep. And there is definitely, whenever you're using cache, there is definitely some extraction that needs to happen, because like
Mm-hmm.
generally, how do you load data? You just do like an async function during
Yeah,
render.
yeah.
But now you need to take that, put it into its own function
You can't
so
do an
that it can be
anonymous
wrapped in cache.
function.
It can be an anonymous function, but the function can't be defined during render, because then you would just be creating a new cache function every render.
Oh, because it
So
uses
there's
object
there's
equality. You can't. Wait, is it because
yeah,
of
exactly,
object equality?
function equality here.
Right.
So you want to make sure that you're not. I guess I should have like started that
Mm-hmm.
podcast off with this.
What
But
the
yeah,
API is? Yeah.
you want to write your cache functions in module scope. So you're going to have, like, you could have, like, imagine you write async function load user, and then that makes a bunch
So
of fetch
so
requests,
so
loads the
so
user, and then you have
here, let's just do the simple version. You have a RSC, and right now it does a wait, prisma.user.find one or whatever. And then it, returns the data, and then it renders it. You want to memorize that. You don't just do, cache it. You don't just do cache anonymous function and then, return await prisma.user.find one, because that would
you
be,
can do that,
you
but you
can do that.
can't define that during render, because then you're defining a new function every render.
The whole
So you
reason you
hoist
want
that
to
in.
the whole reason you want to cache it is because you want multiple components to call that. So you're likely already going to have them in a shared place.
Yeah, yes.
Okay, that's
Yes, most likely. But
that.
there is that extraction step where it's like, I'm probably just have my data fetching in render, I extract it up into its own function in module scope, and then I wrap that function with cache.
I don't understand, because you would never cache a call in one component, right? Or maybe, I guess the component could be rendered in multiple places. Is that?
Yeah, I guess that's one. But yes, most likely,
Yeah.
yes. You would not cache, like, you would not cache a function that's only used in one component. So
Right.
it's basically, now, yeah, like you said, you could be rendering that one component multiple times, and therefore you would want to have it take advantage of cache. But yeah, it's mostly like, you have load current user, you're only
Yeah.
doing it in the layout. Now you need to add it to a page.
You
Step one.
step one, pull it into a lib folder that exports load
Exactly.
current user, and both components now import it. Step two,
Wrap,
memorize. Yeah.
wrap load current user and cache to get
Right.
MLIC.
Right.
Exactly.
Right.
Exactly. That
Right.
would be the
Right.
refactor.
Right. Right. And you have to use memorize in render. Sorry, not memorize. Cache. We keep saying memorize instead of cache. You have two components. You have header and you have chat box that both are now using the awaiting on fetch current user, which is a
Yep.
function in a JavaScript module in lib.
Yep.
And
Yep.
so now you want to memorize them because you notice that they're making the same database call during the same request. So what do you do?
you would use them in render because remember, every request is going to result in a new render.
Yeah.
If you used it outside of render, it would be calculated in
Yeah.
module scope at module import time. And so the whole point is that you have like a sandbox place for requests, and requests get their own render, if you will.
So you would open up both components that are awaiting fetch current user and wrap them both in memo and cache.
No.
You
Sorry.
add it to the lib fold function.
You add it to the lib.
That was my question. That was my question.
I'm going to do this like very, very slowly, but like you have lib folder, and in it you have async function, load current user, await, blah, 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 close function. And then underneath it, you can say export cached load current user, cache equals cache parentheses load current user. So cache takes a function and returns you a new function. Now, generally, you just define this all at once, all in you would say like let load current user equals cache, async, parens, fat arrow, bracket, and then your loading code in there. So it wraps a function. By the way, like this is like one of those things that's just hard to talk about.
No, totally.
On a podcast, if you go look at the React docs, it's going to insta click for you.
Cool. So you get to you could decide if everyone's importing this shared fetch current user function. You go in and to where that function is defined, and then you wrap that function in cache. And now everyone hears they don't know. Yes,
they don't exactly. They don't know. They don't know. That's the beauty.
They don't know. That's the beauty of it. Yeah. Okay, that's very cool. Very cool. I think that's it. That's a good place to stop. But that was awesome, man. I felt like I just got I took a class. You know. Thank you, Dr. Toronto, for your lecture today. It was great on React Cache. I learned a lot about it. No, that was awesome, man. I'm stoked to see your video. So your video is going to be like a little demo, kind of showing some of the stuff off.
Yeah, I mean, basically what I just walked you through was the idea for the video.
Nice.
You know, I'm hoping I can get it all done in under like 10 minutes. But yeah.
Cool. Awesome, man. Cool. All right. Well, hey, look at that. Second week in a row. Fun to be back on the mics. Hit us up on Frontend First FM on Twitter. I kind of want to get like an email too, because like I want people to be able to email us questions or maybe drop something on like buildui.com/podcast once we get that going. But love to hear
that would be awesome. We answer questions. That would be really fun.
Yep. I'd love to have more like interaction with listeners. So, but for now, Twitter's great. And why don't we wrap it there? Thanks for listening, and we'll catch y'all next week.
Cool. See ya.
All right. Bye.